All right, class, we're going to talk a little bit today about Git version control or software version control. It's a really nice tool for keeping track of our software and being able to keep snapshots of what our code looked like at various points in time, being able to roll back with that. It also gives us a lot of help for working with teams and actually developing software collaboratively, as well as giving us a way to move our code back and forth from different machines. So if you're working in a lab or if you're working at home, but you want to be able to jump back and forth and pick up exactly where you left off, Git is a tool that really gives us all of that functionality. Because it gives us a lot of functionality, it's also got a bit of a learning curve. So we're going to spend some time really going over the basic ideas behind Git, and hopefully that will help you as you start using it in your classes, which you are going to use throughout your time here at K-State, and you will again use that further once you get into your career. In fact, this is something that employers are always asking us for. Make sure the students really understand Git. We need them to understand Git because we're using Git pretty extensively. So the first thing we might talk about is how do we actually get a Git repo set up on our local machine. So we want to take some code and we want to turn it into a Git project. So if we already have, for example, maybe a solution project.sln, so we got a solution file, and we have a file for main.cs, and it really doesn't matter what kind of files these are. This could be a Visual Studio project, which is kind of what we started mapping out here. It could just be your English 200 papers as documents. That's perfectly fine too. It will work with any kind of file. It works best with text-based files, so binary files like image files and things like that. The way that Git actually stores the snapshots in time is based on the diff algorithm, and basically looking at how lines change within the file. So if it's not textual, if it doesn't have lines, it's not really the most efficient tool for storing snapshots. So if you're doing graphics, probably use a different tool, but especially for code files and text files, it is great. So we have a folder project. We have some files in it. We want to turn this into a Git repository. How do we do that? Well, what we need to do is navigate to this file at the command line. And then once we get to that directory, so this would be project, and then I'm going to use $ to indicate the cursor. That's the standard for Linux environments. In Windows environments, we would use a caret instead. But because Git is widely used in the Linux world, I'm going to focus on that. So just be aware this $ just indicates the cursor, and then we're going to type the command after it. So in this case, the command is git init. So always the word git before the command. That says the git executable. We're going to run that git executable, and then we're going to run the initialize or init command with git. And if you remember writing console applications, that's what this is. This is the executable. This is those args that are being passed into main. So this is saying the argument is init. And that's telling Git what we want it to do, which is initialize a repository within this project folder. And what it's going to do is it's going to create a new folder inside of this project named .git. And that is where Git is going to store all of its information about that project. And you can open it up, you can look at the files, they're mostly text files, but it's going to basically have all that information. What you don't want to do is edit anything in that. That should all be done through Git, and you don't want to delete it. If you delete this file, you're no longer a Git repo and you've thrown away all that information you've saved. So be aware of that. If you ever do need to take a project completely out of version control and you just want to have the files as they currently are and not have it be a Git repo anymore, that is one of the things you can do, is just delete this file and all of its subfolders, and at that point it's no longer a Git repository. But be aware, that's the nuclear option. That ends the life of that repo. It's no longer a repo, and you can't recover anything that was stored in here after that point. So git init sets us up, gets us ready, and now we can go ahead and edit and commit files. Okay, that's the end of the init folder. And Okay, now we're going to talk about Git cloning. So this is a new video. All right, so last time we talked about initializing a Git repository using a project that we've already started locally. Now, what if we want to take a project that has been created elsewhere and has been hosted on, say, GitHub? How do we actually do that? Well, Git actually allows us to talk to and clone remote repositories. So the command for that is git clone, and then we put in the repo URL. So if you go to GitHub, you would copy the repo URL that it offers as the clone URL, or any other remote repository, because we can do that from GitHub, we can do that from GitLab, we can do that from any Git instance that you're hosting on a publicly accessible server. You can even clone a repo that's already on your computer at a different location by giving the file path as the URL. So that would copy that project from a different folder and clone it into a new location. The second argument you can give, which is optional, is we can give a path that we want to save this to. And that's going to go ahead and drop it in that new location. What this does is whatever this path is, or if we don't use the path, it's going to use the last portion of this URL or the name of the repo to clone and create a project folder at that location. So if our project repo URL was maybe https://github.com/myaccount/project, then we're going to take that name project, create it over here. And then it's going to go ahead and create a .git folder like we talked about with the git init. It's going to go ahead and automatically create that for us. And it's going to copy in any of our files that are in that repo at their current state. So maybe our project.solution and main.cs, or whatever our project names are. So notice we now have a nice repository. Now, a couple things to be aware of. I have a lot of students that do this through Git Visual Studio, where you open Visual Studio and it says, do you want to clone a repository? And they go ahead and paste the repository in. And then they get this arrangement, and then they say, oh, actually, I want this to be my class folder. So I'm going to rename project to be CIS 400 or whatever class that they happen to be in. And then they say, oh, but this stuff is actually for one specific project, so I'm going to create a folder and call that project, and then move these files into that folder. Now notice what has happened here is we have taken these files that were previously kept in the Git repo here, we moved them into this project. Our Git repo now is the CS400 folder. So it's the entire folder, not just this project anymore. So that has thrown away the structure we started with. And now we're also going to keep any additional folders that we put in here for maybe project 2 or homework 5 or anything like that. That really breaks the structure. That's not what you want to do. So if you do accidentally clone that and you really want this in a CS400 folder, the right way of going about that is to go ahead and create your CS400 folder where this project folder is, because I'm assuming you want them at the same level. And then copy this project folder, cut or copy it, and move it into the CS400 folder. Notice that when we do that, we are copying the Git repo folder, the .git folder, as well as all of these. So as long as we copy this whole project and move it elsewhere on our computer, it's still a Git repository, it still has everything connected, and it still preserves that structure. So if you clone it through Visual Studio and you want to move it around, that's what you should do. The other thing to keep in mind is that this folder, .git, on Windows is hidden by default. Windows does not show folders that start with a period in their name, because those are intended to be files that are only edited by the program that made them. In fact, If this is a Visual Studio project, there'll be another hidden folder in there called .vs, which is used by Visual Studio to hold all of your settings describing how you want to display this in Visual Studio. So that's what keeps track of what windows you had open, what files you had open, all of that kind of stuff, which normally we wouldn't commit to the repository, but are going to show up there anyway. So if you want to be able to see this in Windows, you need to go to your settings and basically uncheck the hide system folders, or check the show hidden and system folders. That will make them show up. When you do that, another thing you might want to do is check the box for, or uncheck the box for hide known file extensions. So for example, in Windows, you normally would just see project, you'd see main, it wouldn't show you the .cs or .solution because Windows knows what to open those with. That can be a little disconcerting, especially if you, say, ever created a code file in Notepad and called it .cs or .js or any of the common extensions we use. If you have that setting turned on, Notepad would actually save it as myfile.js.text because it's hiding the text because that's known. And you look at it and it says it's a JavaScript file, but it's not actually being interpreted by anything as a JavaScript file. That is why. So as a developer, you really want to start turning those settings off so that you can see everything. Windows hides them from you because most users don't need to know about that. They don't want to know about that. They don't want that extra complexity in their lives, which is understandable. But as a computer scientist and a software engineer, you really do need to have that level of detail. Okay, so that is Git cloning in a nutshell. This creates for us a local copy of a repository which is kept remotely. And we'll come back and talk a little bit about more in depth about remote and local repositories. But first, we're going to turn our attention to working with a repo once we have it set up locally.